19, okay, there it is, 98, 19. And do you have your engineering handbook?
Yes, right here.
Okay. Is that on the table? And we're gonna take that, we're gonna use that for reviewing and judging, we're gonna get that back here. So it's got your name and all that info on it, that's super. Thank you. So the way we're gonna do this, we're gonna take about 10 minutes. You're gonna explain your project to us, so hit some of the highlights and such, and then we'll have some questions for just a few minutes after that, and then we'll wrap up. So, go ahead and introduce yourself.
Hello, we are the Algonac Robotics. I'm Christian Newman.
I'm Nathaniel Alonzo. I'm Seth Gertman.
Oh, Gertman.
I'm Katie Emery. I'm Shelby Woods. I'm Gabby Cornway. I'm Charlie Amiels. I'm William Fetter.
Eddie Booker.
Thank you. So tell us about your project.
Well, we all came here because we felt like it was such a fun and easy way to learn about further engineering and building such cool and fun robots, and having that vibe of competition for supporting our school. We all decide every part of the robot has someone else's idea and imagery onto it. For example, William Fetter and who was it? Joshua had the idea for the tank treads. Eddie helped out with, had the idea for the final version of the claw. Everyone supported in one way or another, even though we weren't all in the build team, we all had an idea to help contribute to it.
Okay. So everyone was involved, but not all of you actually did the building.
Correct. We had the builders, the programmers, and the funding for it. We have a few sponsors, if Gabby would like to list them out.
I can list them off. Some of our sponsors are the Community Foundation of St. Clair County. We have the Island Machine and Engineering. There's the Algonac Community Schools, which have given us a room to work in, and they've given us a lot of stuff to work with too. We have DT Energy. We have the Michigan Department of Education, Scoreboard and More, Stitch and Style, and SolidWorks.
Okay.
The funding has also done a few more little extra activities to help out with funding besides just asking for the money. Some of them also made some paracord bracelets to sell at our school and around our town. Along with, we had a bank event where every time you put in $1, it would count as a vote, and the top 3 people with the most votes would earn $1,000 or so for their school project.
Okay. Oh, great. Thank you. So you sold bracelets, and then you had a voting fundraiser.
Yeah.
Okay. Very good. Sorry about the noise. Okay, so I guess if you want to explain this, your storyboard, what do we got there, and give us an overview of your robot, and then we'll go down to some questions. If you'd like to explain.
Who wants to explain the
I
storyboard?
guess I'll explain that. So we kind of have taken a little bit of a journey here as our robotics team. Like, first of all, we didn't have a room in the beginning, so we were just starting off, and we were working in the library, and it's kind of like progressed and grown. So this is one of our designs, and this is our first actual design of the robot, and we had like a shoe and an arm on it and stuff, and we obviously have changed it since then. And this was actually at our first competition, so yeah. And then there's just like some different designs that we've phases that we went through with the robot.
Okay, how many of you have been on teams before, and how many of you are new?
The Algonac Robotics team is new this year to our community schools, at least in our area, and so we've all come here wanting to learn more and have fun while doing so.
Okay. Okay, so none of you have been on a, before this year have been on a, wow. Well done just to be here.
Thank
you know?
We did what we could.
What about the other support beyond just like fundraising and getting materials and things? Advisors, other people that have helped you?
Well, we have our coaches, Mr. Sebastian and Mr. Tony, along with some of the adults who will also come in and help keep us on track, or at least try to. And they also help out by driving us around, getting here, also donating some money when possible.
Sure. Did you have any high school advisors or anything like that?
Yes. We have a programmer, and he was helping a lot with programming and coding, and then we also have some other students who've been helping us with
Yeah, they help.
mentors.
And they help us with fundraising, they help us,
Okay.
Tell us more about the design.
Well,
So what you want to know? It's like going for hours.
Well, just explain, what your drive system, your battery system, your conveyor system primarily.
How it works,
So
what's new.
we went with the tracks because of climbing over obstacles and the bars on the ramp. And we put these flaps in to help us get on the bar, and we put plastic dip on these for extra traction. And we put an angle here so we can actually get up on the bar. And we have the motor in the front to help with power. You want to talk about how this works?
Sure.
We have a round plate in here that we machine, and we have motors with gear, and there's a hinge that goes up and down. That was originally for our wonderful Kitty 1.0, and we just decided to reuse it for this since it was so simple to reuse. And we just used some extrusion and then bolted it down. And this actually goes out here and extends here, and then it extends again down here. It's a pain to do, so I'm not gonna do it all the way.
Yeah, be careful on with your motor gears.
show them how the hook works.
So this will flip down. This will go up to the bar. So my arm's top bar. It's too big. Latch on. That pulls off, and then this will pull back down. And this is a winch down here, and this will pull us up.
Because the first time when we tried
We
climbing the
originally,
bar,
we originally had motors here, and when we tested it without all the electronics on, just a battery, it pulled us up, but we slid back down. So we have this gear here, and we have a piece of aluminum on these bolts, so it'll click, and it locks in place on the bolts, because there's a spring.
Okay. And how do you get it to let go? The bar, the winch.
Well, I'm guessing in the end game we're not gonna have power, so we just have to pull it off once they decide that it's been hanging long enough.
Okay.
So we just grab it, and then we pull it down. And in order to undo this, you just gotta put your finger in here, and then you just
As an additional feature on the front of the robot, there's also
That's
the
actually the back.
spinners, the back of the robot. I can't tell what the front and the back of this robot is.
So that's with the ball.
This will spin and it
that'll-
will be able to move the balls.
It
and
flicks the
bricks and
balls away from us, so we're technically not in control. Because you can only control
Oh, I
5 at
see.
once.
Wait.
Will, do you want to come in and talk about the tread design?
Yeah, we have based all the trends off of me and Joshua. Joshua couldn't make it unfortunately, but we've been ever since we heard that we could do tracks, we've been researching and other things to figure out what track's the best, how I would be best at what thing, like for climbing,
Let's see.
and
And how well do those work?
they work pretty good. I mean, they go up the ramp really nicely, and then by the time they stop working, we already have range for this, so I think it'll work really good. Yeah.
Okay. That's the one. Okay. And that's just on the presentation part. We're gonna have a few events from answer questions, question and answers. What's your power system? Is it double battery, single battery?
I only think we're allowed to use one battery.
Oh,
If we could use double battery, we probably would. But we just have a single battery and the battery not zip tied down. Comes straight to there. Pretty simple.
Yeah, what's the voltage? in the battery?
What's
The voltage usually sits around 13 when it's charged. Yeah.
it's
There is
12.
no 13.
It always.
It's a 12 volt
Well,
pack, but it's
that's
when
what
it's
the
charged,
yeah,
it's
most 12-volt batteries sit above 12 volts.
13.2.
Yeah, that's what our software says anyway on the phones. It might be wrong, but I tested with a multimeter and it was the same. So, like lead acid batteries sit really high after you charge them. It might go down after it just sits a while not being used.
Do you have any sensor?
Sensors? No, we don't have any sensors. Keep it simple. Besides, I don't
It's
think
autonomous, right?
autonomous. We actually don't have one yet.
Our programmer just guessed at autonomous mode, so we don't have like exact measurements or the exact time, so he just guessed one.
If it worked, it'd be pretty amazing.
But we are looking forward to trying to get some sensors on so we can do more during the autonomous period, like during the lights and stuff. But we just haven't had the proper time yet to do so because we started pretty late into the season already. But hopefully by next year, when this time comes around, we'll have that ready.
What's the most innovative part you have done?
What's your biggest innovation?
The balls, probably.
I gotta think about that one. Probably this.
The winch system.
Yeah, it's pretty complex. Because we tried to save what we had before, to spare me taking it apart again. Because I've taken this thing apart many times, I don't like to do it. But, so we just used what we had for this and switched to continuous servo so it'd be lighter and easier for this motor down here to do. And we just went based off of that. So we had the idea of just having PVC so it'll slip right off. Got notches in here for our paracord. And the reason we use paracord is because we had some left over from the bracelets. But yeah, that just folds right off. Pull that back. Pull it up.
So, did any of you do the programming? Did
Gabby,
you come
The
forward?
girls back here.
Yeah.
Tell us more about your programming.
Well, we have our high school mentors. We have our high school mentor, so he was helping us kind of learn the basics of it. And then I've been going to Marysville with my dad, and Shelby went with me one time too. And we're part of the Blue Water Alliance, so they've been helping us a little bit with learning it and like.
By Marysville, you mean their team?
Yeah.
Kind of working with their team just to learn some things?
Yeah.
So do you know what programming you have been learning?
We use Appin pattern, the block coding, and Java.
Java. So next year, how are you going to improve this design in the future?
In the future, like I said before, we are going to try to add some sensors and get a better autonomous period because our last event, one short month ago, we got it to work once, but it didn't do any good. So the next year come around, if we can get a better autonomous period, I feel like we can do much more for our events.
and since we have more material now, since we started, I think probably all of us are probably gonna get used to it and starting to recognize the designs and stuff. And they know what to do.
One of the problems that we actually had was, most of the problems that we had to do with the wiring and our battery. Because our battery overheated during one game, the wire broke during the same game that it overheated, and also the battery just kept dying. So this year we run 4 batteries, and after each event that we do, we're going to switch out the battery.
And another problem that we had last event was that for several of our events, the treads broke apart because of the weak foundation. So this time, the girls helped out by lacing it with rubber bands.
But we had to take them off because all the other teams used the black tracks, but we used the gray ones. And since we have these here, we can't really rubber band them. We could, but we've been more complex.
That interfere with the drive.
We
That's what
also-
we had. That's a problem we had before, and they just spaghettified, got everywhere.
We also use these gray ones because these wouldn't fit into the black ones. So we'd get like a bucket and pliers and like soap it in. Like we'd squeeze it in. That just took too much time.
And also, I think one of the other reasons that why the trash kept coming off was because we didn't have a way to block them from the blocks, because the blocks kept getting under. Well, one of the times that me and Tabitha did the driving, it got stuck on a block and we tried to come off and it broke because it was up high.
Yeah.
Tried to get off.
I have some of these tracks at home. Me and my dad were just testing with some little blocks. Actually, if the block hit it here, it would push it inward and snap it out, and then the track would come right back.
Oh, okay.
The thing about
That was one of the challenges, but you think you resolved that, is what you're saying? You hope.
Black
We'll
tracks?
find out soon.
the black tracks are, I think, they're made of a different plastic, and they break a lot easier. It's almost impossible to take this apart without breaking them. These don't break, but they bend easy. So I think they're just coming loose.
I see.
I think you can only use them so many times before you have to bend them back or get new ones.
Okay. So this being your first year, I guess, if one of you could tell us, what do you think is the best part about it? What have you enjoyed most?
But for me, what I've enjoyed the most is getting together as a team and building and learning more about how we can program and build robots. It's just the fact of being with all your friends and doing a thing you like.
Okay.
I also think that just the experience is helping a lot. Like we're developing life skills, like we need to problem solve, we need to come up with new solutions, we need to work together. And I think that it's really bringing us together as a team. And I think for our first year, we've really developed as a team. So.
Very good. Well done.
Thank you.
Thank you. And we're gonna save this. The judges are gonna review this a little later, and we will get that back to you.